All right. Good evening, everyone. How is everyone feeling today? Are you sure? Let's try that again. Good evening, everyone. All right. That's awesome. Hi. Welcome to MCWT X by 2 ConnectNet. Thank you all for coming today. Let's give ourselves a round of applause. My name is Lauren Daniels. I am program manager with MCWT over our career and leadership programming. I want to welcome you all to this wonderful ConnectNet. And before we even get started, I want to thank our partners for this ConnectNet X by 2 who have been some phenomenal hosts in giving us a great welcome with their colleagues, great food, great networking. So again, just want to give them a round of applause. All right, if we just want to go to the next slide, I'll give a little bit more information about ConnectNet. So with our ConnectNets, our goal is to provide thought leadership on trending topics led by industry experts while building meaningful relationships. So for the first part of the day, we did that already, right? We did a lot of networking. We got to know some new people. But now in this next part of our ConnectNet, we're actually going to get a chance to hear from some industry leaders about beyond the hype, healthcare and AI. So we're super excited to get into that. All right, so before we get started into our discussion, we're going to have our sponsor spotlight by Jessica Wu.
Good evening, everyone. My name is Jessica. I'm a software engineer here at X by 2. Thank you all for joining us. It's a pleasure to share a bit about who we are and what we stand for. X by 2 is a software consultancy that serves the healthcare and insurance industries. We're proud to have recently celebrated our 25th anniversary, meaning that for over 2 decades, we've been solving complex problems and delivering innovative solutions for our healthcare and insurance clients. Our consultants specialize in application development, core system modernization, data architecture, digital experience, artificial intelligence, and machine learning. At X by 2, we're focused on building client competency, not dependency. We firmly believe that this is what leads to successful project implementation. By building hybrid teams, we ensure our clients have what they need to scale and sustain their transformation initiatives beyond project end. This method also keeps our consultants engaged and interested in solving new problems. We're small by design. We have around 75 consultants on our team and really focus on hiring intentionally to ensure every person we bring into the company has career growth opportunities from both a technology and leadership standpoint. This is why we partner with outstanding local organizations like MCWT to ensure we're hiring top talent. We've been a proud partner of the Michigan Council of Women in Technology for the past 3 years. Our collaboration extends beyond sponsorship. We've had the privilege of volunteering at golf outings, sponsoring and mentoring scholarship recipients, and participating in events like these ConnectNet gatherings. We have an unwavering and ongoing commitment to building a more diverse workplace, and MCWT has been a great partner in helping us own that and grow as a company. Thank you for the opportunity to share a bit about X by 2. We're not just a software consultancy. We're a community that values collaboration, innovation, and diversity. Thank you to MCWT for this partnership. We look forward to continuing our journey of making a positive impact in the tech industry. Without further ado, I'd like to introduce our panel moderator, Maria Binning. Maria is an insurance technology leader with over 20 years of experience implementing technology solutions. A strategic advisor, Maria has worked in every corner of insurance, most recently moving into the vendor space. She also has a connection to MCWT. Back in 2011 or so, she was part of the team to expand the org beyond the Detroit area into the mid-Michigan area. We're thrilled to have her guide our panelists this evening. If you could all join me in giving a warm welcome to Maria Binning.
Thank you, Jessica. I do appreciate it, and thank you all for being here today. Today we're going to be delving into the topic of beyond the hype, navigating the opportunity costs of generative AI. In a world where all the hype is about, we have tools like ChatGPT and they're stealing the limelight, we will uncover the risks and compromises that companies may make when they're prioritizing generative AI, perhaps over other more substantial AI techniques. We aim to have an insightful and engaging conversation evaluating AI's true impact, tackling ethics and equity issues, discussing data challenges, and leading in the age of AI. It's not just about the buzzwords. It's about making smart decisions that will actually benefit your business. With that, I would like to introduce our panel. So first, let's welcome Mitch Quinn. Mitch is the Director of AI and Machine Learning at X2. With an impressive 25-year career in applied research, he's dedicated the last 15 years to solving real-world problems through the power of machine learning and deep learning. He's tackled challenges in information security, healthcare, and insurance. And we'd also like to welcome Samir Ahmed. Samir is the principal for the insurance market for X2. With over 2 decades of experience, he's been dedicated to creating and implementing innovative technology solutions for insurance and healthcare clients. Samir brings his unrivaled expertise and passion for solving complex problems to everything he does. Thanks, Samir. Thanks,
Thank you.
Mitch. Okay, so before we get started in the heavy conversation, why don't you guys share a little bit of information with us about what your initial experience with AI technology was and how it influenced your professional journey?
Yes, certainly. I can start first. So first of all, thank you all for being here. It's delightful to see so many of you. I got a chance to chat with a few of you already and hopefully chat a little bit more afterwards. My journey with AI, artificial intelligence, it started with, well, back when I was an undergrad studying computer science. In my junior year in college, I had to take some advanced computer science courses. There was a selection on offer, and I chose Introduction to Artificial Intelligence. And that got me, learning about algorithms for searching and planning and optimization, and introduced to concepts like neural networks and robotics, so on. So this was 1999. Things were still very much sort of academic and research-oriented. The state of the art at that time were things like IBM's Deep Blue, which had just beat Garry Kasparov in a series of chess games, or folks at NASA's Jet Propulsion Lab. They were using artificial intelligence to monitor streaming data from the Voyager that was close to Neptune at the time, and preventing, identifying anomalies that might prevent it from going off track. And then my favorite one was a team out of Carnegie Mellon University in Pittsburgh that took a Pontiac van and took it on the No Hands Across America tour. So they drove from Pittsburgh to San Diego, 2,840 or so miles. 98% of it back in 1995 was driven by a computer. So self-driving cars are not new. Anyways, right, this is all academic and research oriented. There was not very much commercial application of this technology. So when I started my career, I stayed away from it for the most part. There were not very many opportunities. I did not pursue it. I did stay in touch with what was going on and how it was developing, and I observed sort of the transition from symbolic representation and processing to techniques that were rooted in learning from data. And this was powered by growth in availability of computing power and access to data and so forth. In any case, in recent years, I've become a user of the technology. I help companies apply it. I'm not a practitioner. For that, we've got Mitch. So,
thanks, Samir. Yeah, so much like Samir, the first exposure I had was also in college, but unfortunately it was like 6 years earlier than Samir. It's like the gray hair may indicate. It was an AI course that I took in 93, and as Samir alluded to, this was very much in the middle of what's known as the AI winter, where AI was, had not lived up to the promise that the previous techniques had, hyped up. And so it was very much an academic curiosity at this point, and had no real commercial applications. So it was a fun course, but it was like, well, we took it because it was fun. And then My work has always been around applied research, where I took cutting edge technology and found valuable business cases to apply them to. And it was around 2004 when I helped found an info security startup. And our intellectual property revolved around algorithms and techniques to detect malicious software in an enterprise network without the need for signatures. So if you can remember back in the day, you always had to update your virus signatures. And those were just like little snapshots of the bad software. Well, we thought it would be useful to be able to detect these things without needing signatures to be developed. And we used an early form of unsupervised learning, which is an AI technique that is kind of on the fringe today. This became really valuable to government agencies who were under attack by custom-crafted malicious software for which no signatures had existed before. So the company did quite well as this tool became a critical aspect of their cybersecurity arsenal to protect them against attacks. And fast forward to 2015, when deep learning began to mature and the frameworks began to become available, like TensorFlow, maybe some of the things you may have heard of today. I used those tools in this company to build a real-time execution blocker. We detected malicious software before it was allowed to run, or in fact, affect the computers that it ran on. In 2016, reinforcement learning came around, and we adapted some of those techniques to simulate a hacker, as the hacker infiltrated and tried to exploit an enterprise network. And we used that technique to great effect. 2018 or so, I transferred this expertise to healthcare, where I worked for a large payer, large health plan, where I used some of the same algorithms that are being used in modern LLMs that you hear about even today. It was a very emerging technology. But we used it in application to care management. Health plans have teams that reach out to people and help them avoid preventable health impacts. And we built some of these algorithms that were able to select people more accurately and get them to the right people at the right time. That had numerous really positive impacts across the organization, not the least of which we avoided a significant number of hospitalizations. And so that brings me to here, which is X2, where I lead the AI practice here as we build impactful AI applications in healthcare, both on the payer and provider side of things, and insurance as well, as we're exploring the new applications. So it's been a long road. It's been an exciting journey, and I think having a front row seat to such impactful technology and being a part of it is something that's really exciting. It sure can be hard to see the forest for the trees sometimes as we.
Sure, yeah. Well, and speaking of seeing the forest for the trees and the immensity of this topic, maybe we can start at the alphabet level here with brief definitions of generative AI and maybe some of the other AI techniques, supervised learning. If you guys could kind of level set the room so that we're all talking the same language.
Yeah, certainly. So like I was mentioning, right, when I took that course about introduction to AI, there's lots of subfields within artificial intelligence. So aspects like robotics and computer vision and natural language processing, so forth. In sort of common discussion, when today somebody says artificial intelligence, they're usually pairing it with ML, machine learning, and usually we're talking about machine learning. So machine learning is a subset, and it has sort of three major sort of subtypes within it. Supervised learning, which is about recognizing patterns from known examples, or unsupervised learning, which is about identifying patterns when no known examples exist, and then reinforcement learning, which is techniques to reach a goal with trial and some kind of reward system. So it's a combination of these techniques that have been assembled in some interesting ways to produced this new field, right, generative AI, which is about creating new information from existing information representing the same kind of patterns that exist in it. And this is what leads to being able to create new writing, new audio, new video, new images, so forth. So this is largely sort of the distinction, right? Traditional techniques are all about learning. And generative AI is about using that learning to create something new that didn't exist before. And when we talk about traditional techniques, maybe Mitch can speak a little bit more about what supervised learning means and what we can do with it.
Well, yeah, so supervised learning, maybe we'll take a step into like the details of it. So supervised learning is a class of algorithms that is mapping input data. So let's think of a really concrete example. Input data, which is like the number of bedrooms in a home, and bathrooms and square footage and location, to some useful output, such as a home sale price, right? And in the ML context, this relationship between that input and the output is not explicitly defined by a programmer or somebody manually defining these rules, but rather it's learned from usually a fairly large data set. For instance, historical home prices and the properties of the homes that are represented. So in practice, the way this is used, the model learns these relationships, and then the model can then take a new home listing and take those inputs and then anticipate and give a reasonable and accurate estimate of what the home will sell for, right? So that's supervised learning in a nutshell. The main advances in this field have been in increases in performance and accuracy, as well as the types of data that they can take as input and output, and output as well, right? So we can look at things now like images, not just regular numerical data, but we can take images and video and audio. And in the care management use case that I referred to earlier, the input data was the entire claims history, all the diagnosis codes, procedure codes, and drugs that a person had taken previously. And the output was this person's risk for a variety of ultimately preventable hospitalizations. And so that was the inputs and outputs in this situation. The size of that data set, it may sound pretty large. It was a collection of about 10 million people's claims history, spanned about 15 years of total history, which wound up being about 1 billion claims. It sounds big, but by today's standards, it's really not as big as some of the truly massive models that are being built today.
Thank you. Thank you both for those definitions. And we know there's a lot of hype and allure. You kind of mentioned it with generative AI and creating new stuff, and and a lot of fear around that as well. But so there's a lot of trade-offs between perhaps using the fancy new tools in generative AI. So let's just start talking about the benefits, though, of using that technology, and then we can also touch on the supervised learning as well.
Yeah. Before we get too far into understanding the benefits, I think it's important to just understand the level of maturity of these technologies. And in our conversation, we're kind of comparing traditional techniques like supervised learning with newer ones like generative AI. So I think most of you are familiar with Gartner's hype cycle methodology, right? Which is a way to identify when you're hopping onto a technology too soon or too late, or you have started using it and you don't give up quickly enough, or you hang on too long, so forth, right? So this, just as a reminder, this hype cycle is a way to identify when there's a trigger for a new technology. It generates excitement, And that excitement feeds off of itself, and ultimately you'll reach this peak of what they call the inflated expectations of what it might do. And there's some early adopters that are trying out the technology. They start to realize the boundaries of it, what it can in fact do, and what the risks are and what the issues are, and so forth, which starts to cause some disillusionment. And that feeds on itself, and you kind of reach this trough. But those early adopters, they stick with it, and they start to get enlightened about what actually can be accomplished and get real benefit. And that's when this becomes mainstream and you start to plateau, right? So this is the rough framework for the hype cycle around new technologies. So in this framework, supervised learning is very much at that mature stage. We know how to use supervised learning. We know what it can do, what it cannot do, what the risks are, what the challenges are, and how to address them. Generative AI, on the other hand, right, is the new kid on the block, came on the scene in a big way November 2022. And excitement's been building, and every now and then I feel like, okay, maybe we're at the peak of these inflated expectations, but the innovation is just so fast that every few months it seems like some new change has occurred or some new advancement has been made. Just 2-3 days ago, there's this multimodal ChatGPT-4 Omni that's available. So it feels like, you know, we're constantly jumping on a new cycle, right, and restarting from the beginning. So maybe we haven't yet even reached peak of inflated expectations, let alone understanding the issues and the beginning of disillusionment, right? So this is just where we are with the technology. Supervised learning, very much mature and mainstream. Generative AI still in early days, just still trying to figure it out. So in that context, maybe we talk a little bit about some of the benefits that are realizable.
Sure. Well, it wasn't always that way for supervised learning. So if you rewind, like now it's in this like really mature, like we understand it stage of what it can do and what it can't. But if you rewind just 8 years ago, this technology was at the peak of inflated expectations. And probably evidence or crystallized by a quote from Jeffrey Hinton, who was a preeminent researcher who in 1993, when we were in the AI winter and that trough of disillusionment, he was building the fundamental algorithms that are used to train almost every single neural network that is being used in AI today. Brilliant researcher, but he said in 2016 that it's completely obvious to anyone who's paying attention that there will be no radiologists in 5 years. So not so good of a prognosticator. But, he was like pretty far off base. But so he was also subject to that peak of inflated expectations. One of the things that it sort of tempers there is this sort of idea that AI is going to take your job, right? So this is just another reflection of AI is going to take your job, but it reflects an ignorance that jobs are not a single task. Tasks can be solved by AI, and you can improve the quality and automate some tasks, but jobs are collections and roles, and much more complex than that. Just as analyzing an X-ray is not all that a radiologist does. So, generative AI does have this hype right now, and for very good reason. The things that it can do are just absolutely astounding. And the diversity of tasks that they can perform just out of the box, and the democratization of access to these tools through web interfaces has shown to the world and enabled the world to take advantage of them has been a rising tide that can lift most boats in some way, right? If you look at the use cases that are useful or like meaningful, it can help. They can help reword. Writers help reword their
intros.
Their intros, maybe.
Felt I better mute.
And,
It worked.
acting like a thesaurus on steroids, and which is really a valuable, it's really an incredible tool for that purpose, and unlocking your writer's block of like just getting started and unlocking that, what you're after. It can also upskill programmers. Like, we found that it's very useful for people learning new programming languages, or to learning, building solutions that use new frameworks. It can really accelerate that upskilling, right? So, the individual impact is small. I mean, these accelerations last for a little while, and you're like, oh, that was very helpful. I produced better content. I produced a better email, whatever. But in aggregate, that impact is quite large if you sum it up over everybody in the prevalence of these tools, right? So, supervised learning models the use cases for those are much narrower, right? They're very focused and carefully crafted, purposeful, like almost like a scalpel, where like a generative tool is like a Swiss Army knife that can do everything pretty well, and the fact that these supervised learning models are very narrowly focused is that there's little concern that our home price, that it's going to go off the rails, right? It's does one thing and does it really well. There's little concern that a supervised learning model that's predicting our home prices is going to say kitty cat. I mean, it's just not. It's just not going to do that. The cool thing about it, though, is that these models, such as the care management model, we use the same brains or the technologies that's used to build these LLMs, the same insides that are used to build these like magical genie LLMs, right? But because we focused how they interact with the world and the business, we can keep that genie in the bottle, right? We can control and apply its use in a way that we can trust that it's not going to cause harm or use, right?
Gotcha.
Yeah.
So I hear genie in the bottle, and I think of Robin Williams, almighty power, itty bitty living space, right? And so it does make me think about that almighty power, and that's a wonderful thing, but there's also risk, right? You can use it for good or you can use it for evil. And so let's kind of identify some of the major risks associated with, again, the learning techniques we're talking about, the AI techniques we're talking about.
Yeah. I guess they can vary, right, from the like banal, very mundane, to like some serious reputational and legal consequences. On the mundane side of things, just uneducated usage of the output of LLMs and just copy pasting them, throwing them in there, winds you up sounding like a bot. Which my kids who are in middle school is like, that's a common pejorative in the schoolyard. You sound like a bot. Which is really I love it. But it can also be like super damaging. There are chatbots that New York City just recently is under a lawsuit right now because they had a chatbot that was using this technique called RAG, but it was used to give information about city policy, and it gave incorrect information, like factually incorrect. So the damage can happen when it confidently gives out incorrect or hallucinates, is the common term that you'll hear bandied about so often. And in this case, it told people that you couldn't be evicted by not paying your rent. And they said, and so they're being held liable for it. Other companies are, and it can go even further that, some companies, there's a recent lawsuit that's coming up that a company that used a chatbot to rank or to actually feed into their HR cycle directly, ranking resumes, right? And it did so in a way that reflected a racial and gender bias that was very inappropriate. So they're in big trouble. And so I think those are some of the risks on the generative side. On the supervised learning side, this like narrow focus that I talked about, of like keeping this thing really tightly focused, is a double-edged sword, right? The act of selecting a use case that you're going to point this scalpel at and like put it into practice for. Requires some pretty specialized skill and a good infrastructure to support it so that you explore that opportunity space to avoid chasing something that may be interesting or alluring, like, oh, it would be cool if we could predict this, but ultimately has very little value, right? And so there's a lot of cases where machine learning models don't make to production because they're just not valuable. And investing in a low value use case is one of the biggest risks for building supervised learning. When I built the care management, when I first transitioned to doing these techniques with healthcare, it was a lot of trial and error. It was a lot of experimentation. So I was exploring the applications of deep learning in the healthcare space, and it wasn't until we were able to collaborate really closely with the business and find that connection and connect the capability with the business value and the data availability that we found that use case in this really special intersection of all three of those components. And so if you stop before you get there, that's the real risk.
Gotcha. So we've talked about, again, the supervised learning being mature, being tried and true, providing reliable answers to very specific questions, right? But it doesn't get the hype and all the buzz that Gen AI gets, right? It's just, that trusty person we just count on. How do we evaluate between, again, your Gen AI and your supervised learning, the business value and the business impact? How do we measure business impact that is being provided by these two techniques?
Yeah, I think it's a very important thing to talk about. So the thing with measurement is, right, that you need to know what you're measuring. And this is where, with supervised learning, right, you have picked a very specifically defined problem. And so you're able to measure performance on that dimension. With the generative AI, right, you have a general purpose model that can do a variety of different things, and it's then hard to measure, what am I actually trying to measure and how do I quantify it? And what we're left with is techniques like using benchmarking, that in this lab environment controlled scenario, it performs at this level. And in this other benchmark designed for this kind of purpose, it performs at this level, and so on. And inherently, right, with the generative AI being about generating new information, which is representing characteristics of what it was trained on, you're operating in this probabilistic kind of domain. And so your measurements are also going to be likelihoods of outcomes, right? The darn thing cannot produce the same thing twice in a row, right? So how are we going to measure it? So it's not to say that these cannot be measured. We're just so early on that we have not fully understood how to measure this in a meaningful way, right? Whereas on supervised learning, we know how to do it because these are so narrowly defined.
Yeah, like some of the allure of generative models and the large language models is that you don't need a lot of data. It's like, okay, we can start with these things out of the box. But there really is no substitute for rigorous evaluation before you go hands off and let you take your hands off the wheel and let this thing drive some important aspect of your business. So there's really no shortcut there, although it may seem like there could be. I think business impact is all about understanding, like you said, understanding the way the model performs with respect to its outcome, and we can do that, right? In my reference, we had a billion claims with supervised learning that we knew what the future outcomes were for these people. You can take a section of that data that the model is learning patterns from and hide it from the model so it never learns from that data, right? And then you can use that data to show it like what looks like new to them, new to that model claims histories, and see how well it predicts what actually did happen to that person, right? And in that way, you can have a pretty good, a pretty and reliable estimate of how accurate or how precise the model can be at the outcome that you need it, the job you need it to do. It's like a job interview, right? You can very precisely understand how it's going to do. But quantifying like business value or business impact, it doesn't end with just some accuracy number or like a data science number. You have to then be able to connect it to the business function or the aspect of the business that you're hoping to improve with increased predictive power. And in our case, that in the project that I built with the healthcare payer, we took this accuracy and ran a simulation of, well, if the nurses were reaching out to a larger proportion of people who actually did have, who were going to have these diseases or these hospitalizations rather, how many more of these things could they prevent? And by doing so, sure, there is estimations and simulations and rough numbers, but you can get a sense of what you could expect the business to be. But it all comes back to understanding how the model is going to perform, and we can do that very precisely with the model as long as it's super well focused, right?
Great, thank you. So you mentioned a few questions ago something about bias, and we kind of skipped over it, but I think we need to come back to it. So where does bias come in? Again, you can tell we're doing this compare and contrast of the supervised learning and Gen AI. So let's compare and contrast in terms of bias, and how do we recognize it and correct for it, I guess.
Yeah, I think it's a very important sort of aspect as well to discuss. But before we get there, right, maybe just a further understanding of how these models are trained and where this bias comes from. So when you have a supervised learning model that you're building for a very specific scenario, you bring very specific data to train it on. And you know exactly what data you brought, you know exactly what characteristics that data has, or at least you can inspect it to know what characteristic it possesses. By contrast, when we're looking at these very large general purpose models that can only be built by the largest of the largest companies across the world, we don't know how they trained, right? We don't know what they used. Folklore is that they trained on all of the internet, right? So there's good in it, there's bad in it. And of course, the output from the model is going to reflect what went into it. So this is one sort of point of comparison, right? That in supervised learning, you have very well-defined data that goes into the training. In these large models, you have no control over what data was used. And that leads to the second part that is worth understanding, that learning is all about feedback, right? You get an outcome, you measure it, and then you feed that back to get better. Well, if you don't control the inputs into the model training, you cannot retrain. You cannot change its outcomes. Whoever was training can, but you as a user cannot. So in the broad scenario, right, with generative AI, the model produces what it produces. You know it's not right, but you cannot affect it to do differently by retraining. Supervised learning, you could do that. To retrain, right, if you identify an issue, you want to retrain, well, if you've already used all of the information on the internet, right, what else are you going to train on? Supervised learning, you can bring maybe some additional data that has not yet been used, or some other aspect of the data that hasn't been used. So these are, when we understand this is how the model training occurred, right, it starts to inform where the biases are coming from. Mitch has experience with this. Maybe speak
Yeah,
a little bit about
sure, yeah.
what we've done to address them too?
Yeah, bias is probably what is one of the most like fascinating topics, like one that I have a particular passion for, specifically related to AI, because I think, you know, like, not to give it away, but I think there's an opportunity. It's something that has to be, you know, considered, but there's an opportunity with AI to make a really huge positive impact in this area, right? So, you know, with generative, as you said, it's impossible to to examine all of the potential outcomes or all of the potential outputs of a model, right? It keeps on going forever. You don't know when it's going to say something that's outrageous, and you don't know when to stop because it just keeps going. And in the more, you know, confined domain, like I mentioned before, we can measure accuracy very carefully. So we have this holdout set of data that we use to measure how accurate the model is. And in the scenario where you have 1 billion claims and you hold out 100 million, what you can then do is you can take that 100 million set of claims. It represents, you know, maybe 10 million people, or no, maybe 5, 10 million. And then you can separate them by demographics. And then you can break that performance analysis down to race, socioeconomic status, you know, ethnicity, gender, all of the aspects that are important to measure when you're trying to ensure that a model is not biased. And this is what we had to do in order to gain the trust that before we unleash this model on 2 million people's lives and affecting, you know, how they're getting benefit from the care management organization, you have to do that. That's table stakes. You have to do that. And so we developed techniques for doing that in areas where we had the data and where we didn't, so that we had that we were confident that despite the disparities in how people interact with the health system and how their data is collected and disparities along all of the aspects coming into the model, that the model itself allocated care and allocated this really valuable resource in a way that was not biased. So the opportunity, you know, comes from, you know, there's a lot, everybody talks about the fear of bias because they maybe don't understand what to do about it. It's all just like, oh, what are we going to do? But once you have these tools in your hand, then AI, which is able to consolidate, think of the decisions that this care management tool was able to consolidate. This was a subjective set of decisions that was made by 150, 200 nurses that were kind of themselves making their own subjective decisions about who they should select to call next, with all their own implicit biases, and, you know, and not to fault them, everybody carries their own. But we consolidated all of those subjective decisions in a way that produced a more impactful outcome. And we did so in a way that allowed us to be able to measure for bias and detect it. And we also developed techniques for correcting that bias. And so it affords a really massive opportunity in its power to take subjective decisions and make them more uniform and make them more consistent, as long as we can apply these techniques to balance out any disparities that they may create. So, I mean, in my mind, you know, that's one of the most like promising aspects of like bias as it relates to AI. I've seen it happen, and it's an exciting aspect of it.
I mean, with one model, you detect a new bias. You have one place to fix it.
Yeah.
Right. With 150 nurses, you have to retrain 150 nurses. Right.
Yeah.
So this is the opportunity.
Yeah.
So speaking of opportunities, before we move on to talking about how do we seize those and capture those opportunities, are there any other hidden costs or considerations we need to think about related to generative AI as we consider our investments in the future?
There are. So, you know, when we talk about these large models, the amount of data that it requires to process, how much computing power did it require? How much energy went into that, right? And there's sort of estimations around this, right? We're sort of concerned about carbon footprint of something like this. Economists, right, they have this fancy phrase, externality, right, that they use for these kinds of things, where you and I, we pay $20 a month for the most advanced version of this. It's, you know, a small, relatively speaking, cost. Why? Because we're not paying for this additional cost that is there, right? Kind of like when you don't recycle a plastic bottle, right? Somebody else is paying for that, right? So there is this aspect to it. A second aspect to it is there's been a lot of investment with all the issues that are there, right? They've been recognized and trying to improve the models, make them safer, or even the training of the models, right? So there's a lot of human labor that has gone into it. And this labor has been, well, in the global south, right? Sub-Saharan Africa, for example, paid very minimal wages. So there's exploitation of labor, right? Again, we don't see this, but it's there. And it's reminiscent of sort of child labor and sweatshop kind of working environments that we've dealt with in textile and clothing 25, 30 years ago. There's a few folks in insurance here, right? So there's this issue with who has liability when you're using a technique like machine learning. And in particularly in the context of when a human and the model are working hand in hand, one transitions to the other. Well, who made that decision? Was it the person or is it the computer? And therefore, who has liability? So this is another area where some hidden costs exist that we have not fully understood. So it's an active area of improving understanding, right? This is not to like spread fear or anything, but just recognition, I think, is important.
Great. Anything to add? No? Okay. Summed it up nicely. Thank you. Okay. So just as FYI, we've got about 10 more minutes maximum of questions. So if you guys are thinking of your own, we've got about 15 minutes or so to give you guys some questions. We've got one or two. We may be wrapping up here. But it is, I think, the best thing to talk about is clearly the landscape is amazing. We've got mature solutions. We've got a relatively new solution. And there's opportunities. How do we, as business leaders, take advantage of those opportunities? Is there some insights you can share?
Yeah, I don't know about insights, but I can share how I think about it, which is that, yes, there's a lot of opportunity, a lot of hope. And we, you know, at X2 in our company, we've had to deal with how do we introduce this amongst our own work and our folks that work here and our clients. And what I've come to realize is that artificial intelligence, right, has applicability at 3 levels. There's applicability that is at a level that is across sectors, across jobs. Really doesn't matter, right? It will apply. And so tools like ChatGPT and Copilot, so forth, right, that are broadly available, whether you're an insurance expert or an automotive expert or a student or a teacher, you can use the tool to some advantage, right? So if you don't use the tools, you're going to be left behind. And so everybody will eventually start using the tools. And then everybody has the same tools. Everybody has the same capability. There may be some transient benefit to the person that got there quicker, but it won't last because others will catch up. So this is a level where you don't want to be left behind. You do want to take advantage, right? The next level is tools that are specific to sectors and segments. So for example, some product that a company has produced for automotive, some product that is there for weather forecasting, something that is for sentiment assessment, so forth. Now, these, anybody that's in that industry will have access to, and there may be some sectors that are more advantaged, others less so, but within the sector, every company will have, again, kind of a level playing field at some point. Some transient benefit if you get there quicker, but eventually everybody else catches up. The third level is when you build your own AI solutions. And here you have a spectrum of options, right? You can come up with a new technique You can use existing techniques but come up with a new model, or you can use existing techniques and existing models but train with your own data. And that is where the real opportunity is, because your data is yours, no one else has it, and what you produce out of it is yours, and that is what will give you competitive advantage if you pick the right one, and it will be enduring because, well, the data was proprietary, no one else can get it. As much as they try, they can build their own, but they can't get yours. So if you think of it right in this way, right, these are 3 levels. Each level requires attention. I think you don't want to be left behind. You don't want to have disadvantage because of the generally available aspects. But if you want competitive advantage, you better be focusing on what you can build with your own data.
I have kind of a similar prioritization in my mind. Like the analogy I like to equate it to is like a diversified investment portfolio, right? Everybody says, like, you know, speculative investment, you should have a certain percentage in very speculative investments. And then you've got, on the other side, you've got some value, which is, you know, storing of value, like very stable investments. And in the middle, you've got your growth stocks, where there's a potential, is fairly well understood, you know, companies that seem to be well managed, that are growing at a good rate. And so the AI techniques sort of fall into those same buckets, right? And depending upon the risk profile of your company, you're going to allocate different percentages to those as well, to those buckets as well. You know, obviously, you know, the generative, like, explorative use cases are those, you know, startups. Those are the VC fund that, you know, it's probably a good idea to have some investment there because it has general benefit to everyone, and you want to be well positioned for when that truly disruptive use case comes about, that you had some stake in the game, and so you're sort of prepared. And I think currently what that looks like is education for everyone. These tools are going to be used, whether you like it or not, in some way, shape, or form. And you need to make sure that everybody knows how to use them effectively and appropriately, and, you know, when not to use them, even if they're not, you know, on the's own. It's just like how to use a calculator. You know, and then also to have a good governance policy where you, like, within your company, you know, you have, you know, very well-informed guidelines for usage, so you don't leak your intellectual property. You know, you keep your data safe, and to provide a safe environment for your employees to take advantage of this rising tide that can, you know, lift all boats just a little bit, right? And you can take advantage of that huge but diffuse benefit right now. And then, you know, on the value side are the table stakes tools that are vendor supplied and specific to your vertical. And in the middle is that growth, which are the applications of well understood AI techniques that can be applied to very specific business problems and provides a significant lever and potential for transforming or making a huge difference in the business. And I think that's where, like, you know, the real investment lies right now. Yeah.
Great, thank you. So to jump onto your analogy of, you know, financial portfolio, some of us work with financial advisors because we may not have the deep, you know, industry knowledge in the stock market and so on, and just feel more comfortable having some guidance along the way to manage our investments. From a leadership perspective in the space of IA, and we've got about 4 minutes, so it might be a, you know, quick answer question, but in the leadership space, as we're business leaders and we're looking to invest in AI, and one area that we need to invest is the leadership within our organizations, is also possibly looking at gaining advice and leadership through partners. So what type of characteristics do we want to be looking out for in those internal leaders as well as the partners we may choose to leverage?
Yeah, I think like probably first and foremost, it's you want somebody who's been doing it a while, who has experience. Experience is like, the positive side of having made lots of mistakes and learned from them, right? So that you, in a leadership position, you don't make them again, so that you have a good steady rudder and can be most effective in how you apply your investment, right? And I think also you want somebody who, like when you're partnering or like starting to do this, you need somebody who has the same passion for the internals of your business and those high value problems as you do, that has that connection, but brings that experience in AI to the table. Because it's only in that really tight collaboration. You want somebody who can teach you enough about AI to be dangerous, and you teach them enough about the specific business to be dangerous, and it's only in that close collaboration and really, that strong partnership is made that forges something that's just like some geeky, exciting, like high performance model, but forges it into something real, right? Something that can actually make a big difference. And I think those are, like, in my mind, those are the two like key aspects that you need to make sure you have when you're looking to explore this landscape.
Yeah, and I think Mitch has helped me shape my perspective on this, right? You can get this capability as a leader from the outside, right? When you're starting out, maybe in a part-time kind of fractional capacity. That can eventually grow into a full-time role. One of the key things, though, is that this is not a skill that you want to be learning as you go. At the leadership level, yeah. Right? Within the team, yes, you can transition from one job function to becoming an AI engineer, for example. But if you're guiding the company on where to make your AI investment, right, you don't want to be learning as you go. You want to have somebody that has been there before, knows how to make these decisions. And this is not to say there won't be trial and error and experimentation, right? There will be. But they've been through that process with this. So they have the battle scars to prove it too.
Yeah, it kind of is analogous with the supervised learning, right? Where you've got this mature, tried and tested and validated and matured and structured model that has continued to get better with time and with modification, and that's what you need with that leader, is that's had some of that kind of battle scars and reworking of their leadership skills and their knowledge before they come in and try to
and there's
lead
a lot
something
of roles,
else.
Right? There's like the chief data officer, chief analytics officer, CIOs, and like a lot of people come at AI from different fields. Some people come at it from math, some people come at it from computer science and engineering, and it really is sort of this like melting pot of disciplines in this field. And so, I think you can find someone that has that connection or has that experience in many different aspects inside your organization as well. And so it really is a case-by-case basis. But
Excellent, excellent. Well, we are going to get to questions now from the audience. I know you probably are bursting at the seams. We've certainly spent some time here quickly. We hit the history of AI. We learned that AI is not really new. It's been around for a while, quite a while. Again, we talked about the supervised learning being more mature and tightly controlled than we've got our generative AI. And there's benefits and risks on both sides of the equation. Certainly the supervised learning, we've worked through a lot of those and they seem to be managed a little bit better at this point, primarily due to maturity, right, and the length of time that they've been around. With that, so it's been a really entertaining conversation thus far from my perspective, and I've had this conversation like 5 times in 2 days. And it's still really interesting. And it does. And I learned something.
It's like generative AI, you don't know what's going to come out of our mouths.
Pretty much, yes. So with that, please, we will have somebody walking around. I think it's Hannah will have a microphone handy. So who would like to ask the first question? Please don't be shy. There we go.
Hi everyone, I am Abhi. I have 2 questions about healthcare insurance data and all the HIPAA rules again. How do you ensure how do you ensure quality and ethical use of data when using it for generative AI?
For generative AI, yeah. So that's really tricky. You know, I think you have to bring a lot of that. So a lot of those techniques need to be either brought in-house, right? So, or you use them in a protected cloud environment that is HIPAA compliant, that you can then transfer that data to. That's like SOC 2 Type 2 and HIPAA, a high trust compliant cloud environment, so that you can then leverage compute to take advantage of it. Like HIPAA is a really fascinating thing right now, because just there's this conflict right now between privacy and protection of privacy and the utility which that you can use the data for. And sometimes they come in conflict and constrain the applicability of some of the models, because you don't have access to data that would otherwise improve the performance of a model, because you don't know that the person was homeless. You don't know that the person had, you know, things in their history that were documented in doctor's notes that you didn't have access to because it was sensitive information. And so sometimes it ties our hands, right? And so it's a very, I mean, that awareness it's a very delicate and very precise, you know, thing that you have to do. It's like weighting the privacy and wanting to do something meaningful with the data. But I think the cloud environments are mature enough that, you know, you can use some of it. You know, it all depends on your organization's governance policies and openness to being able to deploy and use that in those environments. But definitely don't put it in ChatGPT.
And I would just tease apart, you know, your question. I think there's two sides to it, two parts to it, right? One is having to do with HIPAA, which is what's allowed, right? The other part you asked is about ethical use, which is whether it's allowed, is it the right thing to do, right? So I don't know that anybody can answer that other than the people doing this work. They have to just kind of make sure that's right.
And the next question is, like, I'm starting my career in data science field. So, I mean, what do you, I mean, based on your experiences, what would you suggest me to focus on to be relevant in AI in insurance field? Because I am working with Roosevelt Innovation, who like mainly work with dental insurance data. So, any suggestions and from your end to me?
Yeah, it's great. I wish I was starting new again, because I want to see as much of the future as I could, right? I mean, it's exciting, right? I mean, I think the one thing that is like really listening to the people who are using the models that you're making, right? It's cool to be able to create models, and it's like really exciting, and you can see the potential of them. But until you're able to effectively communicate how they work in a language that they understand in their domain, you know, a Rocky you see does not speak to an ED physician. I mean, it doesn't relate. But when you can show them that when they ordered this lab, that the model predicted that he was going to admit, he can go, yes, that's when I knew. And that builds trust in the models. And doing that change management of like understanding the sensitivities of the people who are going to be affected, or the stakeholders in the work that you produce, is probably the most valuable. That's going to unlock your technical creations and enable them to have a much broader impact, because they'll be trusted and accepted by the people who need them the most. Yeah.
Thank you.
Yeah.
Got a question up here? Oh, one back there. Okay. We'll go back there first, and then we'll come up to the blue. We'll go. Okay.
Hello, I'm Kimberly Donaldson, and my question is, what's next?
What's next?
What's next? I mean,
Yeah.
this is so 2022.
Yeah.
So what's going to happen?
Well,
on the horizon?
I think what you're going to see is like the trajectory that they're already on, with being more integrated in your life, right? With the multimodal models for GPT 4.0. I mean, this is something that's going to sit with you while you're working. It can view video and be like completely integrated in real time. That's pretty astounding. I think there's going to be an increase in capability of the models to the point where, you know, the question of if it can reason or not is almost a moot point if we can't tell whether or not it's actually reasoning, and we have to doubt ourselves, and people assume that it is, then it's as good as it being that way. So I think there's a lot of societal impacts that we'll have to address, or like have guardrails around, the deployment of these things. I think you'll see a lot more regulation, or like there's going to be a little, a push for regulation, both from the incumbents to try to protect their position because they have the resources to navigate the regulation, but also from the people who are scared about the impacts that the AI might have more broadly. But as far as like the sci-fi thing of like, I don't know, I don't know what's coming up next week. I mean, I think they're going to get smarter, and like, where does that end? It doesn't really seem like it's like saturated yet, or that there's any real. The advancements keep coming at a fairly steady pace. They haven't really gotten boring yet. It's like we reached peak iPhone a while back, and iPhones are now like, meh, yeah. But every time OpenAI or Gemini releases something, it's like, oh, what? And it's just jaw-dropping. So, I mean, to that end, I don't think anybody who's not like down in the trenches of the big companies that are doing this like really know, right? And I think they're discovering it too, right? They're like testing the limits of what they're able to achieve, and so they're finding out as they go along as well. It's a good question. I wish I knew the answer.
Next question. We've got, yep, right there in the blue.
My name is Anna, and I share your fascination with bias, especially veering towards, and you're going to hate this, but the generative side.
Yeah.
And I just wanted to know, and this is a loaded question, so whatever you're most fascinated about, but what are, like, the most common biases, especially in the healthcare and the insurance spaces that you're seeing right now and testing right now?
Yeah. Well, most of the biases arise from a difference in how socioeconomic groups and different races and cultures interact with the healthcare system. Because if you think, if you don't have insurance, you can't have a regular primary care physician, or you don't have a relationship, and so you go to the ED when something happens, right? And the data that is present for those underserved populations really constrains what the model has to learn from for them, right? And it's really spotty, and so that is one of the sources of bias in the models, is a misrepresentation in the data that they train on. In generative AI, it's so much harder to measure, right? Because it's just like out there, and bias is an interesting thing, right? It's inappropriate bias is the thing that we're most concerned with. Bias is a useful thing to making a quick decision, right? Because if I don't give pregnancy tests to men, right? It's like that's a bias. It's like a snap decision, but it's grounded in but it's less clear. Like when a model has such expansive usage, how do you test how it's going to be biased, or what the impact of that bias might be? If we're giving assistance to someone versus punishing someone with a model, right? So, rejecting them for a loan versus giving them care management assistance, the way you measure that bias is very different, and it's dependent upon how that model is being used. And when you have this general model that's being used for everything, everywhere, all at once, you can't say, well, it needs to be corrected in this way, because the correction is dependent upon the use case, right? And the tools that they use to measure the performance of the model is this like chicken and egg thing. The outputs are text, and so they use another language model to evaluate whether or not the output of this language model was biased. And it's not there yet. They're really not there yet, but they're working on it. I mean, that's why it's an interesting field. It's being worked on, but it's really not there yet.
one other aspect on bias, just to take it a little bit further, right, is again, it's a story of hope and despair all at once. With models that are one place where you process information and produce decisions, right, you get one place to detect it. But when you don't have that, right, it's dispersed across many decision makers, right, you don't get the opportunity to detect it. So these biases that exist that we don't even know about yet or haven't fully understood, right? So like in the insurance context, right, well, if you're in this zip code, you get higher rates for your automobile insurance. If you're in this zip code, you get lower rates, right? So is there bias in that? Well, if you unpack it, well, zip codes represent some socioeconomic group. And so, well, because you're charging more for insurance, they don't get to drive a car, right? This already exists and it has nothing to do with AI.
Yeah.
Now what's going to happen is when a machine learning model is making this decision, all of a sudden you have a place to measure it and it will seem like, oh, it's biased.
Yeah.
When the bias has existed all along.
Yeah. But like with generative, the other thing that's like maybe a little bit more subtle is, the way the models are trained is they're trained to predict. That first starts out with like you give it a sentence and it predicts the next word, then it predicts the next word, and it learns language in this way. It learns to manipulate how words are fit together. But then there's a second aspect of the training that's called reinforcement learning from human feedback, and what that involves is the model is given a prompt and it generates two responses. And then a person looks at those two responses and says whether one is better than the other, right? And this is very expensive training data to create because it requires some pretty, you have to be able to read it and then you're giving a thumbs up and thumbs down. Well, they developed this technique to make the most use of the least data, right? From an economic perspective, right? It makes sense because these cost like $5 each to create. So you're not going to generate millions of them. The consequence of that is that all those people giving thumbs up and thumbs downs their voices are being amplified in the output of the model because this is this huge amplification effect of that input. And the transparency of who's doing this and what their guidelines are for giving a thumbs up or a thumbs down, what is better, which one is better, also doesn't feed into what's incorrect, or they could both be terribly wrong. But this one is like, well, this feels better, but they're both wrong, but okay, let's go with that. And so I think that leads to a bias that's not transparent, and they don't really have a good handle yet on how to tune reinforcement learning to completely eliminate it. So that was a good question. Yeah, it's a big field.
Well, it is 8:15. I know that Samir and Mitch are going to be around for a bit longer because we didn't hit a lot of the questions in the audience, but we will be inviting Lauren back up to close out the evening, and we'll be mingling around a little bit if you've got additional questions. I do think we should give these guys a round of applause. They've been amazing.